All right, so we're going to talk about parallel and perpendicular lines. Now, what does it mean for two lines to be parallel? Yeah. They'll never meet as they continue outward forever to infinity and beyond. They will never, ever meet. So, what does that mean when we look at an equation of a line? Yeah.
It would have the same slope.
It would have the same slope. So, parallel really means same slope. So, write the equation of a line that passes through 12,5 and is parallel to this line. The only thing that I care about from this line is its slope. So what this really tells me is I'm going to pass through that point with a slope of 2/3. So to do that, this is exactly actually what I was about to show. So that's convenient that we came over here. Once I know the slope of a line, and I know a point on that line, the process gets pretty easy, actually. You know it's a line, so you know it's going to be in y equals mx plus b form. What things can I plug into this equation right now? The x and the y, and the slope. So plug everything that you know in. My y value at a point on this graph is 5. But at that point, my slope had to be 2/3. And to get that y value, I had to have the x value of 12. And then there's probably some constant that helps make this happen. So start to simplify and evaluate. 2/3 of 12 is 8. Well, what would b have to be to make this work? You can either figure it out in your head or solve the equation by combining your constants. B, we find, is -3. We're not done. We're almost done. That lets me then write my equation y equals 2/3 x, gotta have that slope, minus 3. Or plus a -3, but that's redundant. So when you know a point and a slope, you plug in the point and the slope to find your y-intercept, then write out your equation. Now, perpendicular is where this gets hard. So, capture that. Move to perpendicular lines. Come on. You got this. I promise.
In this problem, you will classify lines. Are the graphs of the equations 4 times y equals -5 times x plus 12 and y equals 4/5 times x minus 8 parallel, perpendicular, or neither? Explain.
Parallel will have the same slope. Oh, and sometimes, don't let this throw you off, you could have a line right on top of the same line. They are parallel, even though they touch. If they have the same slope, we call them parallel. So either they never touch or every single point touches. So that's a weird manipulation, but occasionally they'll throw a question in there that's like, what's a parallel line? It goes through this point, and then it ends up being the same line, and it just kind of confuses you. Perpendicular lines. Anyone know how their slopes will relate? Yeah.
They are the opposite reciprocal.
Slope will be the opposite reciprocal. Some people say negative reciprocal, but I like opposite because if it starts as a negative, then it's going to become positive. Roll, I think it's CAL. So, if we're trying to classify lines, I need to first put both of these in a slope-intercept form. So to do that, I would need to divide by 4. And 12 divided by 4 would be 3. Then I compare the slopes. If one line has a slope of 4/5 and the other line has a slope of -5/4, these are perpendicular. Because they have opposite reciprocal slopes, that means that they are going to hit like this. And you could see this if you throw them into Desmos or something like that. We can see that perpendicular relationship. By the way, I think I forgot to write x. I can't let that slide. -5/4 x. Negative 5/4 x plus 3.
So could the whole fraction be negative?
So to make a fraction negative, either the numerator or denominator or out in front of the fraction, but there just has to be one negative symbol. So negative 5/4 x, what was it, plus something, plus 3. So there's that first line. My other line was y equal to 4/5. What was the intercept on that? Negative 8. See how where they meet? It's a right angle. So you can graph it and see it as well, but the reason they have to be opposite reciprocals is if one's a positive slope, the other one's got to have a negative slope. And it can't have the same slope as a negative, it has to have the reciprocal slope, because if you think about rise over run, your slope here is really saying go down 5, right 4. Your slope here is saying go up 4, right 5. So it's doing like the inverse of what this slope did when you swap around the rise and the run. So if I needed to, what I'm really looking for is finding an equation of a perpendicular line. There we go.
In this problem, you will write an equation of a perpendicular line. Which equation represents a line that passes through the point 2, 4 and is perpendicular to the graph of the equation y equals 1/3 times x minus 1? Your choices are A, y equals 1/3 times x plus 10, B, y equals 3 times x plus 10, C, y equals negative 3 times x minus 2, and D, y equals negative 3 times x plus 10.
A negative 3, the opposite reciprocal, and then I know my point is 2, 4. So just follow that slope-intercept form process. Plug in the y that you have, 4, the m that you have, negative 3, the x that you have, 2, and we don't know our b. So now 4 equals negative 6 plus something. When I add 6 to both sides, I get that b is equal to 10. So then that makes my equation the slope of negative 3 and my y-intercept of 10. There we go. Just determine your slope first, then plug it into the equation. Other questions about parallel and perpendicular lines? Yeah.
On the test, it says that make a line that's parallel to y equals 4.
So the line y equals 4. When you think about if y is always 4, what sort of line is that? Horizontal. So what sort of line could you make this parallel to that?
Another horizontal line.
Any other horizontal line. Or if you needed to be perpendicular, any vertical line. So you can make y equal to really anything, as long as it's just a constant. Other questions from chapter 3? Yeah.
So for like the do you understand problems, I'm having 2 difficulties.
That would be a great problem to plug into Desmos and compare the graphs. So Chaitna's looking at one of the questions that says, how are these different? How are they similar? And this goes back to what I was showing you with that parabola. How whether it's inside or outside changes what it does. So you have y equals the absolute, by the way, absolute value is right down here if you're working in Desmos. The absolute value, it has a, but that's of an expression that you're working with. Absolute value of, what is it, Chaitna?
So like the absolute value of x plus 2.
X plus 2, like all inside the absolute value?
Yeah.
And then absolute value, oh, well that's interesting. Didn't know that would do that.
Just
X, and then on the outside plus 2, right?
Yeah.
So when I look at these graphs, What did the purple's plus 2 do? The top graph. What did that do? Compared to the parent. So compare each of these to the parent function of y equals absolute value of x. How is the purple compared to the parent function? Jocelyn?
Okay, so on the purple one, it made it go. Made it shift to the left, which made the x change to -2, and with like the orangish one, it made the y change to +2.
Yeah, so the difference here is one was a horizontal shift and the other was a vertical shift. But what's the similarity? Right? Doesn't it ask for similarities and differences, Chaitna?
Yeah.
What's the similarity? They both did what? They both shifted the graph, right? So both of those shift the graph, but the difference is one, like the top one shifts horizontally and the bottom one, or the middle one there shifts vertically. Because a change on the outside is always a vertical change. Walker, stay with us. Change on the inside, next time you get the squirt gun. Change on the inside is horizontal. Change on the outside is vertical.
Can I be the guy with the squirt gun?
No. I also like to lift desks and then drop them.
Really?
Yes.
Didn't you do
If your head is on your desk and you're asleep,
Flip the desk.
Speaking of that,
be you have been warned.
Flip the desk.
That was so funny.
Noah.
I had so you guys won't believe this, but
I can be your
school
official desk
used to
flipper.
be very different, right? So I had a high school. Well, I think we're done with parallel and perpendicular lines.